You just do the broadcasting.
Okay, so what happened? So in earlier terms, we have seen that students are facing issues in finding the limits, right? So let's see how to find the limits and everything. Okay, so I'm going to share the slides in like 2 minutes. So let's see. All of you are okay with the content in week 4?
Yes, sir. Yes, sir.
Okay. Yes, yes, we are going to solve periodic questions only. Yes, correct. So yeah. So my screen is visible, right?
Yes.
Yes, sir.
Okay. So go to the joinperiod.com and use this code IFXNEP. Okay, so use this code. So 9 students are joined. So I'm going to start the session. Okay, so this is the first question for week 4. So this is the CDF of a random variable x is given by fx of x equals to 1 minus e to the power minus 7x and x is greater than or equal to 0. Okay, so for x greater than or equal to 0, we have CDF as 1 minus e to the power minus 7x and it will be 0 otherwise. So otherwise means for the values taken by x less than 0. The question is find the probability that x is less than or equal to 10. So these are the options. You have to write the option there.
Sir, is the streaming working okay from your side?
No, no. So, streaming is not there. So I'm going to record the session now, and then
Okay.
the link will be updated later.
Yeah, that's great, sir.
From the previous,
That-
something has happened, right? I don't know.
Yeah, we missed the recordings. But sir, tomorrow is Dussehra festival, and
Yeah.
I don't know whether.
I think that's why very few people have joined today, I think.
No, sir. Actually, the main concern is whether the team would be available to upload this lecture or not.
Yeah. It will be there. So the team will
The
be
team,
there.
the team will be there. Okay.
Yes. So the video get uploaded by tomorrow itself.
Yeah, because sir, tomorrow is the submission.
Yeah, I know. So we will try to upload it by today.
Tomorrow is not the submission, sir. Submission is on 7th.
7.
Is it?
I think
Yeah.
deadline is extended, right?
Yes,
Okay.
Friday.
Due to the Dussehra, it has been extended by 2 days.
Okay, then it's fine,
I
right?
have not seen it. Sorry.
Okay, it's good, right? Then. Okay. Anyway, the submission. So the video will be there. Okay.
Yeah.
Video will be there.
Okay, sir, solved it.
Solved it. Okay, fine. Okay, I got like 20 responses. So I think okay. B. Okay, okay. It was not okay. Correct. So most of the people have given the correct answer, I guess. So yeah, it's very easy, right? So you just have to plug in the value of x there.
I want to ask one doubt.
Yeah,
Actually, it's a
fine.
general doubt.
Fine.
Sir, I am confused in that suppose a is less than x is less than equal to b. So where should we consider that equal to sign and less than sign? Because when the CDF is given in one of the activity questions, it was a less than equal to x less than b, like this form, but it was some contrast to the definition. So could you clear that confusion?
You wanted to say that between a and b, how it will be fx of b minus fx of a, you're saying?
Yeah.
Is
In
that
CDF,
a doubt?
sir. Yes, in CDF.
So I think he's asking CDF is described in
Explain,
terms of
basically my
probability x
question
less
is
than equal to it.
Okay, less than or equal to.
Please
It is less
explain the
than
definition.
So the definition of CDF is provided that let's say x is less than or equal to small x, correct? So you are saying that whether if it is provided that x is less than or small x is same as that of provided that x is greater less than or equal to small x, is it?
Yes, sir. Actually, if you could explain the definition in somewhat detail, sir.
Okay.
I'm getting confused in that. Less than or less than equal to.
Okay.
When x lies between two values.
Okay, fine. So actually, okay, you understand, at least you understand this question, right? So all of you have
Sir, I am able to solve these questions, but I am confused in the definition. How to treat that
So can I explain
and less than equal to sign?
Fine. Anyone can explain, fine. I'm just trying to, in between you can explain it. I'll just, yes, go ahead.
So we know that the definition of CDF by default is probability of f of a, let's say.
Yeah, just go ahead. I'm just trying. I'm audible, right?
His mic is
you are audible. You are audible, sir.
Okay. So what is the definition of CDF? Okay.
F of a equal to probability x less than equal to.
Go ahead. No issue. I'm just trying.
Yeah, that's the by definition, right? But now we have two options. Either the x can be a continuous random variable or it can be a discrete random variable. Suppose it is a continuous random variable, then we know that probability that x equal to a is always 0.
Yeah, that I know, because x can take value around that a, but it can never be. We cannot be very sure that it takes the value a. We cannot state it very surely.
At a point is 0. We have discussed it few times in the session, right?
Yeah.
So at that instance, if you say it's probability of less than or less than equal to, then it becomes equal, right? If it is a continuous random variable. Yeah, but if it's a discrete random variable, then there is a difference. So there you cannot go. If
in discrete we have to look for the jumps it is taking before that value, right?
Yeah. So if I say, let's say x equal to 3 with probability 1/2, right? So at x equal to 3, there is a jump. So you cannot say equal to 3 is equal to less than 3. No, the probabilities are different there. But for
Yeah,
continuous,
because
you can say that, right?
Okay.
in discrete, if there is a jump at that point, then the probability exists at that point, right?
Okay. So okay, what is
You
CDF
mean to
first
say?
of all? CDF is a cumulative distribution function, right? So it is that like we are going to aggregate the probabilities, right, over the range of that random variable, correct?
Could you make the screen a little bigger, sir?
All of you are right. Okay, fine. I'll try to do this. So
Yeah, now it's okay, sir.
it's too much.
Okay.
Okay, so CDF of a random variable is what? It's a cumulative distribution function, and we can define it for a discrete random variable as well as a continuous random variable. But we know that CDF is a continuous function, right?
Yes.
All of you
Yes,
agree
sir.
with this? So you
Yes.
don't have any doubts, right? Like whether it is a discrete random variable or whether it is a continuous random variable, but the CDF
It's always
it will be continuous, correct? So continuous. Okay. So by definition, if you wanted to say, so if a function is continuous, what does that mean?
at every point on the real number line, it is
Yeah.
different.
So let's say x. This is x and this is f of x. So it is a function of x, and some let's say it is going from 0 to 1, right? And suppose some graph is sort of like this, it is there, right? Okay, so at some point x here, okay, suppose at some point x here, if I wanted to find the probability at this point, what will be the probability here?
0.
It will be 0, right? Because since it is a continuous function, for continuous function what we actually find is we'll find the probability like when approaching to that function, right?
Yes.
Is it correct? So
Yeah.
so fx of x, right? So or in this case, let's say for continuous function, what will be the definition of a continuous function? So we are going to find okay, let's say maybe
continuous function means there is no break,
right? There is no break, and that what does that mean? So when I wanted to find any value, we are generally going to find in a certain interval, right?
Yes.
At a point we are not able, because at a point it is not differentiable, right?
We can
but
take
then
2
the
points.
function is
X and
continuous.
X
Sir,
plus
CDF
So-
of discrete random variable is not continuous, sir.
It is continuous, right?
No,
CDF
is always continuous.
CDF is always a continuous function, right?
CDF is
is
for random variable. CDF is defined as a continuous function for the discrete random variable also. It is by design, it is made continuous.
right. So because we are just adding, right? Okay, so what happened in discrete random variable? We are adding probabilities for different points, correct? But for a continuous random variable, so continuous random variable, it is always already a continuous, right? And we are going to integrate over that
Sir, it
interval,
is a
and
step function for the discrete random variable. CDF is a step function, sir.
okay. Anyway, it is a step function. It's fine, but is it not a continuous function?
No, it is not
Why not?
continuous. It is step function, sir. So step function is not a continuous function.
No, 1 minute.
It may be continuous from the right, but it is not continuous from both sides.
Sorry, I was yeah. Okay, what you are saying?
It is continuous from the right, but it is not continuous from both sides.
Yes, sir. There is only right continuity in CDF.
Yes, sir.
For discrete random variables.
So it is non-decreasing function.
It is non-decreasing, okay, but it is not continuous.
It is defined at every point, sir. Its domain is real number, but it is not continuous.
Continuous from
discrete random variable.
Because there are breaks, na, sir. It is jumping from one,
It is
like
a step
one value to
function.
another.
It is a step function.
Okay,
Step
fine.
function is not continuous, right?
Okay, fine. So okay, let's suppose okay, fine, that let's say it is not a continuous function there, and you are saying that, but if you wanted to find probability at any point, how will you find that then?
Sir, if there is a jump in the CDF, that means that at that point there is a probability. There is a probability of that function having a value at that particular point. If there is, suppose, a jump at 2 of 0.2,
correct.
and probability of 2 is 0.2.
Okay, so okay,
So
so
what we can do is we
uh,
can find a value of the function just before x, and we can subtract that value.
yeah, generally we do like this, right? So we are actually so we'll treat it as a continuous function only. So it's generally what happens is okay, so let's say it is a discrete random variable. In that case, how the CDF will look? Suppose okay, can you tell me any random variable where
Sir, die.
so yeah,
In
let's
terms
say
of a die.
suppose yeah, so let's say we have 1 2 3 4 5 and 6, right? Okay.
Yes, sir.
Okay.
PDF, am I correct?
Okay, I'm talking about PDF first. So let's say we'll have PDF of this random variable. So the probabilities will be, so let's say 1 by 6. It's a fair die. Consider this as a fair die. So CDF of this function will be what?
It will be a step function, sir. At every step, the height of the step will be 1 by 6.
X equal to 1.
1 2 3 4.
At every step, height will be 1 by 6.
So it will be from 0 to 1. It is 0, right? Okay.
Yes.
And then here it will be 1 by 6, correct?
Yes.
Then again it will be constant over this interval 1 to 2, and then we'll have again one jump, and it will be 1 by 3 here, and like this, correct?
Yes,
So
this is not a
1 by 2.
okay.
Yes. This.
So okay, but yeah, it is not continuous exactly at that point, but it will be continuous over here, right?
Yes, sir.
So
This is right
between
continuity, sir.
so yeah, that's what. So that means let's okay, we will. Okay, I'm just not going to say always. Okay, fine. That's fine. Okay. Let's remove this. So in this case, how will you find the probability that, let's say, fx of what? What do you want to find?
Probability, sir, not ffx.
Okay.
Probability of x equal to some value, like
let's say the probability that x will lie between
2 and
2 and 4.
sir.
So maybe let's say 2 and 4. So how will you solve this question in discrete random variable case?
So probability of 4 minus probability of 2.
So it will be probability that
no, sir, fx of 4.
fx of 4, right?
4 minus fx of 2.
Correct.
Minus
right?
probability
It is
of
not
x
less
equal
than or equal to, it is just less than, sir.
yeah. So what we can do is we can write it fx of 4, sir.
X is less than 4 means
Less than
we
4
don't
means,
have to take it is
Guys, we can subtract probability x equal to 4 separately. Now we can write it fx of 4 minus fx of 2 minus probability x equal to 2.
Okay, in this case
sleeping.
Okay, so
it is 3 by 6 by minus 1 by 6, which is
somebody is making noise.
My God.
Oh,
he's literally sleeping.
Okay, so yeah. Okay, so here, okay, can you tell me how to find this provided that x will be, so in this case what we have to find actually? We have to find the probability that x will take value less than 4 and it will be greater than 2, right? So in this case okay.
So we can use fx of 4
okay, let's say okay, I will take this one fx
minus
of 4
fx of 2 minus fx of 2 minus one more minus,
okay,
minus probability of x equal to 4.
Yes, sir. Yes, sir.
Okay, so okay, how this will look is okay, so this is the case, right? Fx of 4 minus fx of 2, and okay, can you tell me what is fx of 4? It is probability that x will take
less than equal to 4.
Less than or equal to 4, right? Correct. What is this? Fx of 2 is probability that x is less than or equal to 2.
Yes.
Okay. So probability that x is less than or equal to 4 means what? This probability, right? All the area between this, correct?
Yes.
Yes. All of you are agree with this?
Yes, sir.
Okay. Okay. Then what is probability that x is less than or equal to 2? This area, right?
Below 2 here.
This one, correct? The red color area, right? And when I wanted to find x is less, probability that x is between 2 to 4, what does that mean? Which probability I'm interested in?
Equal to 4, sir.
Huh?
Equal to 4.
What equal to 4? No, I'm
What's
just.
the question, sir?
The question is, if I wanted to find this probability that this one, probability that x is between 2 to 4.
The area.
What does that
the
mean?
Area between
Which
them.
area? So it will be between 2 to 4, right?
Yes.
So I know that it is probability that x is less than or equal to 4, right? So this is
Yes.
what this is the addition of all the probabilities until x will take a value equal to 4. So this will be what? Can you tell me in this case, if it is a fair die, in this case, what will be the probability that x is less than or equal to 4? It is equal to probability that x equals to 1 plus probability that x equals to 2, right? Plus probability that x equals to 3 plus
Yes.
probability that x equal to 4. And I am interested in what?
Less than 4.
Less than 4. So we should exclude this probability, correct?
Yes, sir.
Right? And what is probability that x equals to 2? It is probability that x equals to 1 plus probability that x equals to 2. Right. Okay. So that means this one, right? This portion.
Sir, I have a question, sir.
Huh.
So this area thing is like not right. Like it's CDF. We cannot area of CDF doesn't give us anything.
Huh. That's what. So
it's the PDF's area that gives
this PDF. Right? Yes, correct. So,
sir, I have one question. Sir, first day we learned that if we calculate CDF and the function is discrete, then we have to add the probability, and if it is continuous, then we have to integrate it.
Integrate, correct.
Yes. Then where we should apply this formula, fx4 minus fx2?
No. This is two different things, right? One is discrete random variable, and another is continuous random variable, right? So when discrete random, we can use fx of 4 and fx of 2 anywhere, right?
What's our addition and integration? Both are the same thing.
Both are same thing, but the thing is,
addition for discrete and continuous integration for continuous function. This is okay, but
doesn't matter whether it is a continuous function or not continuous function. Integration means summation over a whether is a function is a broken or it is a continuous.
No, that is correct, right? But yeah, anyway, this is
question is about fx of 4 minus fx of 2. He's not understanding how to subtract like CDF.
When I should apply this one for calculate the probability?
That's what sir is telling now.
So this is what, right? I see. Okay, fine. Okay, let's see. We will see the differences between. So we are just checking for this one, right? For discrete, and now we will check for continuous also. One question will take on continuous, and one will take on discrete.
Sir,
then you will find
first finish.
Okay.
Sir, first finish this discussion, sir. Sir, so, I have understood. Sir, one please.
So in general, okay, 1 minute. So actually, if you wanted to find probability that x is between 2 to 4, that means we are going to find probability that x equals to 3, right?
Yes, sir. Yes, sir.
And that is what we have done here, correct?
Yes.
So here so probability that x equals to 4 is this one, right? This complete.
Sir, for discrete purpose, it is x is equal to 3, but for continuous purpose,
I will say okay. What I'm saying is this. We'll check on continuous also. Okay, then it will be clear, I think. So for here you understand, right? At least discrete you are understanding, right? What we are going to do. Okay.
Sir, I have understood till probability of x less than or equal to 4. These are probability of x equal to 1 plus probability x equal to 2, probability x equal to 3, and probability x equal to 4.
So I'm okay. Okay, I'm going to write it down here. Like let's say here it is, right? X equals to 2 plus probability that x equals to 3 and plus probability that x equals to 4, right? So this is fx of 4. This is what I have written, right? Now
Yes.
minus, okay, minus, all right, fx of 2, which is what? Probability that x equals to 2 plus probability that x equals to 1. Okay, is okay?
Yes, sir.
Now we wanted the probability that x should be less than 4 and it should be greater than 2. So for x is greater than 2, so this is nothing but what? Probability that x should take value less than 4 minus probability that x should take values greater than 2, right? So probability that x is greater than 2 means what? Probability that 1 minus probability that x is less than or equal to 2, right? Okay, I'm sorry, it's written here. So here, what is this? This is probability that x is less than or equal to 2. So why we are subtracting this? Because we wanted the probability where x will take values greater than 2, right? And then
yes, sir. Yes, sir. Yes.
And then now when I said that this constant is there less than 4, then I'm just subtracting the probability that x equals to 4. Then I will get the value probability that x equals to 3. So I can directly find the value of x equal to 3, or I can find it like this. So suppose, let's say I have changed now to this one, probability that less than or equal to, so x will take values less than or equal to 4. In this case, what will be the answer?
Sir, we have to take probability x equal to 4 also.
3 and 4.
So now
3 and 4.
So in that case, we have to remove this part, right? We don't need to subtract x equals to 4, right? Correct?
Yes.
Yes, sir. Yes, sir. So
Yes,
we have to
sir.
look
Yes,
into
sir.
the
Because we are-
condition, sir, whether it is equal to or it is only less
Yeah.
than.
So now in this case, what will be the probability?
2, 3, and 4.
So in terms of CDF, how can I write this?
Sir, in first case, when it was 2 less than x less than 4, it was only probability of x equal to 3.
X equal to 3.
Just this one, na?
Affects 4.
Correct. That's what.
Affects 1.
So now in this case, what will be the probability of x of 4? So how can I write in this terms?
Probability of x equal to 2, x equal to 3, and x equal to 4.
We can
Right?
write
So 2, 3,
Now
and
we can
4.
subtract. We have to just add probability x equal to 2 to this same.
Right. Or I can do like this, right?
1.
Effects of 1 we can do.
Fine. This is also fine, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Or I can do like this, minus and plus probability that x equals to 2. Since I need to include this. So this less than or equal to, and these things will be important when we are finding the probabilities for what? A discrete random variable, right? Okay.
Yes, sir.
Okay.
Okay, sir.
Now we will move to continuous random variable. So for example, in our case, okay, I think the random variable is not defined, right? Only CDF is given. Okay, fine. Okay. So CDF of a continuous random variable, how it look like? Let's say the function is e to the power minus x is there, right? So how this graph will look like? So let's say
This is PD. This is function or this is CDF.
Okay.
1 minus e to the power minus x we can take, no? So it will be exponential distribution CDF.
Okay, we will take the CDF directly, right? So CDF of an exponential random variable will be what?
1 minus.
It will be 1 minus e to the power
minus x,
right?
Minus lambda x.
Yeah. Okay. Lambda here, consider lambda is 1. Let's consider lambda as 1. Okay. In this case, so let's say fx of x is, so here x is my exponential random variable and the CDF of this function is 1 minus e to the power minus x. So how this graph will look like is when x is equal to 0, it will be 1, and I think it will
be
it will start from
go to 1.
No, it will start from 1, right?
It start from 0, sir. CDF it is.
No, sir, it will start from 1.
It starts from 0, sir, and then it approaches 1 as the
Yes,
birds
sir.
increase.
Yes, sir. It's CDF. If it was just the PDF, then it would have started from 1.
Okay, 1 minute.
But it is
I
the
just-
CDF, sir.
Let's say.
Yes, sir. To have a valid CDF, it should start from 0, no, sir?
Correct. That's right. That's right. So I think we have written something wrong here, no? Then.
Okay.
No, sir, it's right, no, sir.
Sir, if you write the PDF, that is
you put-
e raised to minus lambda, then it will start from 1 and then it will go down. If it is the PDF.
Okay, 1 minute. Let's start with PDF first, then we'll find CDF. Okay. What is the PDF of an exponential random variable?
E raised to minus lambda into e raised to minus lambda.
Right. So in
start
this
from
case,
1.
yeah,
Let's start from 1.
It will start from 1, right?
And slope down.
Okay. First of all, I'll write fx of x. Okay. Okay. So when and what is the range of x here for exponential distribution?
0
it will
to
from
infinity.
0 to infinity, right? Okay. In this case, so when x is 0, it will be 1, right? It will be 1, and as it goes ahead, so I think
sir,
it will
slope down.
So this CDF is correct only, na, sir. You put x equal to 0, 1 minus 1 is 0, coming out to be 0, sir.
Yes. So yes. So I thought
CDF
what I thought is e to the power minus x, right? I thought it's 0 and I just started with 1. Okay, that's fine. Okay, I understand.
Yeah, it's correct, sir. It's totally correct. I've checked the equation myself.
Okay. That's fine. Anyway, I thought of integrating it. It's fine. Okay. Okay. So it is fx of x is this one, right? Now I need to find CDF, right? So for CDF, it will be, what is CDF?
Start from 0, sir, and slope
1 minus
1 minus e to the power minus x. So how it will look like?
Start from 0,
go
sir,
to 1.
and
okay. Start from 0, and what is the shape of it?
Going upwards, sir. Curving upwards.
Yeah, and it will go, I think, like this.
Up to 1.
Yes, sir. Y equal to 1 means asymptote.
1 to, yeah. One at 1 it will not meet, right? Right. So it will go like this, right?
It will approach meet at infinity.
Yeah, fine. So this should be the CDF. Okay. In this case, let's say I wanted to find the probability that x is less than minus it's positive. So let's say x is less than 3. Okay, probability that x is less than 3. So suppose 3 will be somewhere here, right? So this is a continuous function. X is a continuous random variable. Here x will start from 0 and it will go up to infinity. Okay. So if I wanted to find the probability that x is less than 3 means which area?
No, not this area. So this is CDF.
CDF area
not
is not important.
So here, how will you find it?
Just the value
Okay,
value of the function at
fx of 3
okay,
basically.
1 minus
fx of 3 will be equal to what?
1 minus e raised to minus 3.
Probability x.
Right. Okay. So this is fx of minus 3. Okay. Now can you tell me? I wanted to find that probability that x will be between, let's say, 3 to 5. In this case, what will be the answer?
Fx of 5 minus fx of 3.
So fx of 5
minus
fx of 5 minus
fx of
fx of 3, right?
E raised to minus 3 minus e raised to
Right.
minus
So
5.
let's say, okay, I'll write that. So it will be 1 minus e to the power what? Minus 5 and minus of minus. So it will be minus 1
minus 1
and
minus
plus e to the
plus
power minus 3. So let's. So it should be e to the power minus 3 minus. Okay. So answer we are not okay. Now can you tell me what is this? Probability that x is greater than 3 and less than 5.
So you have written
Same,
less
sir.
than or equal to 5.
Same, sir. Equality doesn't matter, sir. It's continuous
Right?
random variable.
Correct, right?
So yeah, sir, this is the doubt actually. Why the equality does not matter here?
Because it is not a discrete random variable, right? So in discrete random variable, what
There are jumps, right? We have to consider the jumps, and jumps do matter.
Yeah, jumps, right? So at that point, some probability will exist. So here, what happens is, at some point, right, the probability is equals to 0. We are considering the probabilities so in PDF, so in this case, right, when we are saying that 3, so we are just taking this area, right, when we are finding the probabilities, correct? So we are not finding probability at this point, we are finding probabilities around that point, right? For understanding it?
Yes, sir.
So here there are no jumps, and so here in this case, when I say probability that x is greater than 3 and less than or equal to 5, this is same as that of probability that x is greater than 3 and less than 5.
Sir, is it due to the fact that the sir explained in the lecture that one taking by epsilon?
Epsilon, yes.
Means
So
that
epsilon means,
because
yeah,
epsilon is very, very small.
small.
And
So this is
adding a very small value to a probability does not matter at
correct.
all. Is
So,
it the point?
yeah, so this is, yeah, that is what I'm trying to say. It's around the point means it's plus epsilon and minus epsilon, right? So it is we are not actually, so that small point does not matter here, right? So it is approaching the probabilities, right? So whatever sir has said, it is same thing, because it is a continuous function. All the properties of continuous function
Now
will
I understood, sir, why
applicable to this.
whether it is less than or less than equal to, it
Doesn't
hardly
matter.
matters because it's a very, very small
value, right? Yeah, because greater than 3 means what? It is 3.00001 something, right? And 5 point, so less than 5 means it is 4.9999 something, right? So how much difference it will create, that minus epsilon? Nothing, right? When I say less than or equal to or only less than, it doesn't matter. In case of discrete random variable, what happens is, when I say x is less than 5, then it will directly go to which value? Value of 4.
Yeah, 4 point something, 4.9 something.
No, in discrete it will be like, it is a gap, right? So between the values.
Yeah.
But in case of continuous, less than 5 means what? It is very small value, right? Because it is a continuous function. We are just talking about, when I say x is less than 5, it means it is the probabilities until what point? 4.9999 it will go, right? And when I say greater than 3 means what? 3.0000 something, right?
Now I got it crystal clear, sir.
Right. So when I say less than or equal to or less than or whatever, so in all of the cases this will hold true, correct, for a continuous random variable, right? And when I wanted to check for discrete, then we know that, like, how to
we have to consider the step whether it is existing
right
at that point or not.
Right.
At
Okay.
step we have to calculate the probability.
Correct, right?
And we do have to take that probability or we don't have to take that probability.
Okay. So so all of you understand, right, what I wanted to say? So actually, when I say that probability that x is something, so it is, we are taking the probabilities around this point. Since it is a continuous function, we are taking all the values around this point, right? So actually, and that's what we are taking this small, the strip, and we are integrating over it. So the small strip means what? It's delta L, right? So it is like very small distance, and we are integrating over all the range of that random variable, right?
Yes.
So integration means it is a sum only, but since it's this interval, the delta L is very small, that we have to integrate over all the delta L, and when I do this, I'll get some the probability. It is same, but here what happens is we have so many values that we have to consider it as a continuous function. So I think we have studied in the lectures also that how to go from a discrete to continuous, right? I think sir has mentioned somewhere. Maybe skip. Okay, but
Yes,
okay,
sir.
that's it, right? Yeah?
Yes, sir. Let's move to the second question.
Okay. So we will see like how to find the limits also. So yeah. Okay, now you can tell me. Find the value of probability that, so same function is there. We have to find the value of probability that -2 is less than x is less than or equal to 4. So in this case, can you tell me
Sir, let us
what will be the value?
Sir, give us time to solve it.
Okay, find it. So whatever we have discussed, we have to use the same thing, right?
Sir, I do not remember the function, sir.
Okay, let's write it down somewhere.
Done, sir. Thank you. Answer.
Yeah, okay, fine. Just wait for some other responses. So 14 I got. So all of you please try. Whatever we have discussed is like
Is it B? Oh, sorry, sir. Sorry.
okay. So others are solving or is it done? About 22 responses.
Answer.
Yeah, B, 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 A, B, B, C, A, B. Okay, all the answers are there. Let's see the solution. So yeah, so is okay now. Now what happened here is x is a continuous random variable, right? And it is having CDF, which you have seen there. Now we have to find the probability that x should be between -2 to 4. And here, okay, if I go back, so what is the range of x?
Greater than 0.
Okay, right?
Greater
So,
than or equal to 0.
0. So when I say probability that x is between -2 to 4, that what does that mean?
It is basically x is equal to 4.
Fx of 4 minus fx
Less
of
than 4.
Fx of
Fx
4
of 4, sir.
minus fx of
So,
4.
so no
So
matter fx of -2
Fx of
because it is less
-2
than
is
0.
0, sir.
Yes,
Oh,
yes,
correct.
yes, sir.
You
So it
understand,
will be
right?
0, but still it is
Yeah.
fx of -2 will be 0.
Okay. So it will be like this, right? Fx of
Yes,
4
sir.
minus fx of
Fx
-2,
of
and I know that fx of -2 is 0.
0.
And if I add this, so it will be 1 minus e to the power -22, right? So which is the correct answer here? Option
A,
A.
sir.
A, right? So I don't know, like okay, somebody has found B, C, and D. So can one of you, okay, you wanted to explain or you understand, right? So those who give those answer, you understand this solution, right?
Yes, sir. Yes, sir. Actually, I didn't notice that x is greater than or equal to 0, sir.
Yeah.
I
So
only
yeah,
noticed
so
the
range,
function.
correct. Range
Yes,
is
I understood,
important.
sir.
Okay, range is important. Okay, fine.
And
Okay.
again, sir, probability cannot be greater than 1. If e to the
Yeah, that
power
correct. That we have to always think in the mind, right? So probability cannot
What is
be
this, sir?
probability cannot be less than 0, and probability cannot be greater than 1. So
Okay.
always when you find the answer, you just cross check once. Whenever in the exam also, you can, this is a like, okay, sometimes what happens is we'll solve question and we'll have some answer. Just check that if we are asking for probability, that means it should not be greater than 1 and it should not be less than 0. Okay. So the question number 3 here is, let x be a continuous random variable with the following PDF, and fx of x is given, so it's a PDF. It is k into x square plus 4. So what is the range here of x? It is between 0 to 1. Okay, so find the value of k. So, and then assuming that it's a valid PDF. Okay, find the value of k.
Done, sir.
Yeah. So I think I got 7 responses. Let's wait for like 2-3 minutes and then we'll see. Huh?
Yes.
I think week 4 is somewhat easier, right? Like not. What I feel is like a calculation point of view and everything. I think it's not that difficult. It's just we have to be very clear with. Yeah. If you are clear with the concepts, I don't think like it's up to.
Most of it's stat ones, sir. Nothing new has like.
Yes, week 4. Yes.
But for the week 4, you require a mathematics integration.
Somewhat, little bit. Yeah,
if you are zero in the maths like me, then it is very difficult. I have to put a lot of hard work to understand the calculus.
Yeah, like little bit of maths too we done now. Then
yeah,
but
so actually this integrations, right? It's not involved like too much of complex.
No heavy like no integration by parts and all those things are not.
Yeah, it is not there. Only see now it is, if it is x square. So what will be the integration of x square?
X cube by 3.
X
cube by 3, right? And if you have plus sign here, that means it is. So whenever there is plus or minus sign is there, we can actually separate the two
terms,
right? So here we can separate k square and 4k, right? And what is the
Yes.
integration of k square?
Not so k is that k is the
K is a
K
k is
constant.
a
by
constant.
Yeah, so kx cube by 3. And what is the integration of 4k?
4xk.
4xk.
xk, right? And then we have to put the limits. So mostly in our course, it's not like too much of x cube or x raised to 4 or x raised to 5 or something x square into e to the power x. So that multiplication of two random variables, it's not there. It's basically, it's very it will go around only with
Simple
this.
one.
Yes, yes.
When
11th class, 11th standard mathematics is
yeah. So here also, see, I think 11th and 12th standard we have that x into e to the power x or x into log x or
We have that,
something like,
sir.
right?
It's
So
even easier
integration
than that.
by parts. So this is again somewhat complex. I don't think it is there here, right? Okay.
Yes, sir. The focus here is like to understand the concept.
To
There's no
understand,
point
yes.
in playing with mathematics.
Okay. So I think I got like 22 responses, and yeah, still they are all over the place. I think all the values, but I'm seeing the common value is 0.23.
Yes, yes, yes.
Okay. Let's see. So we'll see the solution now, right? Okay. So yeah, what is the property of a PDF? So over the range, when we take the integration of PDF, okay. So sorry, here is the mistake. So it should be fx of x into dx, right?
Yes.
It should be equal to 1, right? When we integrate over this PDF through the range, it should be equal to 1. So here the range is between what? 0 to 1. And because other values it will be 0, so we are neglecting that.
Sir, what
So,
we are basically doing in this step is that we are converting the PDF to CDF and equating it to 1.
Correct. Because that is a property of CDF, right? The sum of or sum of not here. Let's say integration over the PDF is equals to 1, right? Yes. Because
the sum of area under the curve is total area
it should be equal to
1.
1, right?
Yes.
Correct, right?
Yes, sir. Yes.
So that is what we are doing. Okay. So sorry. So here, like I said, it should be k into x square plus 4. So either you can do one thing, you can just take k out and just integrate over x square plus 4 dx. So it should be x cube by 3 plus 4x, and k is anyway constant, and the limit should be from 0 to 1. So if I plug in all the values, so first in this case what you have to do, you have to plug in 1 first and then minus 0, right?
Yes.
Okay. Do I need to do this or is understood?
Understood. Sir, the point that
for all of
was
you
raising in between.
So because I know that a lot of people forgot.
Yes, it's understood. Mistake in integration.
One thing, sir. The point he was raising that like PDF is like the derivative of CDF, right?
Correct.
CDF.
Correct. That's correct,
right?
Yeah.
What we are getting is f of 1 minus f of 0 should be equal to 1. That's what we are saying, right?
F of
1, fx of 1 minus fx of 0 should be equal to 1. That's what we are saying, right?
Yeah, that is correct. Right. Correct, right?
Yes, sir. Yes.
Okay. That is correct. So this is actually the area between 1 and 0, right? It will entirely be equal to 1 only. Okay. So yeah. So here if you plug in the values, you will get k as 3 by 13. So what is the value of 3 by 13? I'm not sure. So
comes up to 0.2
and 0.23. Yeah. 0.23, right?
Yes.
So the value of k is 0.23, and that should be the correct answer. Okay, so those who did not get that answer, just check it once. Maybe the calculations mistake would be there, right? Okay, so with the same CDF or PDF given there, you have to find the value of probability that x is between 0 to 1 by 2. Okay, can you find it?
Yes, sir. Yes.
So can you tell me what should be the approach here? So will you go with CDF or will you go with PDF?
We can integrate the PDF from 0 to 1 by 2.
That is also one part is there. Other thing is?
CDF, sir.
We
CDF.
do not have
you can
CDF.
find
No, sir.
the-
PDF is given to
You
us.
can find the
You
CDF.
can
No?
find, you can
You can find the
integrate
CDF.
this PDF. You can integrate the PDF
Yeah.
between 0 and 1 by 2.
Yeah,
0
but
and X.
then even you have to integrate and then you have to
Yes,
put up the
yes, yes.
values.
Same
Again, you are
thing.
doing the same thing.
Yeah, same thing. It's nothing different. Okay.
Done, sir.
audible, right? So 0.97 and 4711. Okay. Okay. At least all the values are between 0 and 1, so I'm happy. So, yeah. Okay. So that's how you understand, right? At least we should know that the probability value should be between 0 and 1, right? Okay, now we'll see whether the answer is correct or not. So there may be chance that you made the mistakes in calculations. So yeah. So here, if I wanted to find a probability between 0 to 1 by 2, that means you are going to integrate the PDF over 0 to 1 by 2. And what was my PDF? It was k into x square plus 4. And then we have found the value for k in the previous question as 3 by 13, right? So it is 3 by 13 into x square plus 4 dx. And again, the same calculations you need to do. It's just that in the previous question, what we have done is we have plug in the values of 0 and 1 in x. Here you have to plug in 0 and 1 by 2. So anyway, so if you plug in 0, it will be 0. So 1 by 2 cube by 3 plus 4 into 1 by 2 minus of 0. So if you do the calculation, it should be 49 by 104, and I think it should come around 0.5, right? Less than 0.5, I think. Yeah.
Right.
So
It's
what?
0.47.
0.47.
Okay.
Yeah.
So then 0.47 should be the correct answer, right? Okay. So everybody understand, right? This one? Okay. So I'm assuming that you are understanding. So if any problem is there, you just tell me that at that point itself. Okay. So this is the conditional probability you have to solve. Here, let x be a continuous random variable with PDF as fx of x as 3x square. And okay, think about the range. So range is between 0 and 1. And it should be 0 otherwise. We have to find the probability that x is less than or equal to 1 by 2 given that x is greater than 1 by 4. Okay. So use the formula for conditional probability first and then apply the integration or whatever method you want to use.
So it is still in previous page even for me.
Yeah, sir, you haven't changed the slide yet.
Sorry, what happened?
So you haven't changed the slide yet in
It is
Clear
still
Deck.
showing the previous page in PD.com.
Oh, I think so. I'm not sure that it. No? Okay, fine. I have changed here, right? So it should change.
I'm sorry, it didn't
Shown
change.
only.
Okay, I think there is some problem. Okay, can you write your answer in chat box, but only to me? Okay. So MA1004.
Sir, in Zoom only we can send personal messages, sir. Here
Okay.
we shown to everyone. Sir.
Okay. So yeah. Okay. Just write it there. We'll discuss the solution. Okay. I know. So don't write in the chat box. Also, it's fine then. Just keep the answer as it is with you. After 2-3 minutes, I'll explain.
It is done, sir.
Okay. Let's wait for 2-3 minutes. Still, because others, I'm not sure. Like others have done. So,
It's done.
because okay, fine. Just wait 2 minutes. Wait. Anyway, we don't have much questions today. After this, only 2 questions are there. So it's fine.
Where to enter the answer, sir?
I think there is a problem in this slide. I think it's periodic is not updated with this. I think so. Just keep with you. This is the solution. Okay, so I'm assuming that everybody solved the question or at least attempted the question. So we'll see the solution. So it's similar as that of previous one. The only thing is here we have conditional probability. So can you tell me what is the probability that A condition B or A given B?
So the X
So
will
it
lie
would be
between 1/2, 1/4.
yeah. Okay.
Probability of A and B divided by probability of.
So probability of A and B divided by probability of B.
X
So
less
in this
than
case, what
equal
is
to
A
1
here?
by 2.
A it is X is less than or equal to 2. And what is B here? X is greater than 1/4. So that means the conditional probability should be probability that X is less than or equal to 1/2 and
Greater than
probability that
1/4.
X is
X
greater
is
than
greater than 1 by
4
probability
divided by
that
what?
X is greater than 1
X
by
greater
4.
than 1 by 4.
Greater than 1/4. So here you see. So the solution is provided that X is less than or equal to 1/2 and X is greater than 1/4 divided by probability that X is greater than 1/4. So how to solve this? So we know that in between it should be integrate. We should integrate between 1/4 to 1/2, right? That's right. What is the intersection or what is the common values will come between 1/4 and 1/2? It is okay. Anyway, the same thing I'm saying. So it is between the probability between 1/4 and 1/2. So integrating over 1/4 and 1/2, 3x square dx, and probability that x is greater than 1/4. That means we should integrate from where to where? From 1/4 to the upper limit. So what is the upper limit of so what is the upper limit here? It should be 1, right?
1.
Because the range of x is 1.
After that,
0 to
probability
1.
is either way 0, right? So,
right. So we should integrate between 1/4 to 1. So integration of 3x square dx is what? X cube, right? So 3 get cancelled, right? 3x cube by 3. So 3 get cancelled. So it should be x cube. And x cube in the numerator it should be 1 by 4 to 1 by 2. In the denominator it should be 1 by 4 to 1. So if you find the answer, so in the numerator it should be 1 by 8 minus 1 by 64 divided by 1 minus 1 by 64, right? So it should be 7 by 63, right?
Yes.
Yes, sir.
Correct. Is correct?
Yes, sir.
Yes,
Yes,
sir.
For the
Yes, sir. Bilkul.
denominator, sir, can I go to the previous slide?
Yeah.
Yes, sir. So for the denominator of probability of x greater than 1 by 4, can we put 1 minus probability of x less than or equal to 1 by 4?
Yes, you can do that. You can do that. So the integration limits will change, right? So 1 minus probability that x is less than or equal to 1 by 4 is what? Or maybe tell me what is the probability that x is less than 1 by 4. So what will be the limits? 0 to 1 by 4, right?
Yeah.
1 by 64.
So 1 minus integration
1
from
minus
0
integral
to
of 0 to 1 by 4.
4, 3x square dx.
3x
If
square
you
dx.
find in that way also, the same answer will come. Okay. So this is 7 by 63. So just find it in the, I don't know, like what is the answer? So 7 by 63 is around
1 by 9.
0.1. Yeah, it is very near to 0.1, right? Okay. Right? Okay. We move to the next question then. Okay, here also we don't have, I think, that updated with this. So just tell me, okay, this answer you just tell me right now itself. So let the CDF of a random variable x is given as fx of x equals to 0 when x is less than 0, 1 by 4 when x is taking values between 0 and 2, and 1 by 2 when x is taking values between 2 and 4, and equal to 1 when x is greater than or equal to 4. So question 1 is find probability that x equals to 0.
1 by 4, sir.
It is 1 by 4.
1 by 4.
1 by
1 by
All
4.
of you are sure?
Yes, sir.
Yes, sir.
Yes, sir. It's a jump.
Okay. Think this as a continuous random variable x.
0.
It is discrete, sir, not continuous.
No, we cannot, sir. There is jump in CDF.
What I'm saying is, okay, what I'm saying is the CDF of a random variable. So in this case, let's say it is a continuous random variable. In this case,
0. 0.
Then it is 0, sir.
Right?
Yes, sir.
Then it's 0.
Correct,
The
right?
given CDF cannot be the CDF continuous random variable, right?
Why is it 0? Because of continuity.
Yeah.
Sir, at 0 there is a jump, so it is not.
Yeah, in this case it is
Easy
not there. But let's say if it is a continuous random variable, then in that case, the values for probability that x equals to 0 and probability that x equals to 2 will be what?
0.
0 and 1 by 4.
Should be
1 by 1 by 4.
okay. In this case, it's correct. But I'm saying that okay. Let's remove this CDF here. So suppose you CDF of a random continuous random variable. In that case, we cannot able to find the probability that at a point, right? So in that case, it will be 0. Okay. For this case, what should be answer question 1 and question 2?
1 by 4, 1 by 4. 1 by 4, 1 by 4. 1 by 4 and 1 by 5, 1 by 2. 0.5.
1 by 4.
No, sir, 1 by 4 and 1 by 4. 1 by 4.
1 by 4 and
1 by 4 both.
Yes.
1 by 4 both, right?
1 by 4 both.
yes, sir.
Okay. Okay. This is the question number 7. So you have studied standardization, right? In this week. Standardization, have you studied?
Yes, sir.
Okay. So the question 7 is based on standardization. Okay. Now the question 7 is the test scores of the statistics portion in the qualifier exam are normally distributed with a mean score of 46. Okay. And if the standard deviation of the score is 15, then find approximately how many % of the scores are between 16 and 61. Use the following CDF values of a standard normal distribution. Let's take some time and solve this.
So for the previous question, how was probability of x equal to 1 by 4?
Okay, we'll come to that. Okay, after this question will end, we'll come to that. That's fine.
Okay.
Sir, can we just
Can you share
discuss
the-
like standardization a bit?
Okay, you guys want to first of all try it out, or just you wanted me to explain that standardization?
So,
Sir,
like,
first we want to
if
try out.
someone is we can discuss it. So if someone wants to try, he can try it. Who knows?
Okay, fine. Let's discuss this. Just give me a minute. Some noise is there. Can you mute there? Okay. So, what is
So what is the standard deviation, sir? Just
for this question? Standard deviation is, I think, 15. Suppose. So standardization is that suppose you have a random variable x which is a continuous. Okay.
So please question once more.
Is it not visible on the peer deck?
No, not visible.
Is it?
It doesn't load at all.
No, so it's visible on peer deck.
Okay, I don't know. I think I haven't updated this. Okay, that's fine. So you mean like only 4 questions are there, right? Which are seen. Okay, I'll just update this peer deck before giving it to you.
Questions.
Okay, no issues. So this question is fine, right? Shall I go to that?
No, sir. Just
slide?
wait. Just.
Okay.
Okay, sir. Now can you?
Okay, right? So x is a continuous random variable. With mean equals to mu and standard deviation equals to sigma. Okay, so if I wanted to standardize this one, so what I'll do is I'll
IGs,
just
can you people like mute? So there is some disturbance.
That's fine, right? So what standardization means is when you wanted to convert any continuous random variable into a normal distribution with 0 mean and what one standard deviation is 1. How will you do that? You just have to subtract what a mean, right? You have to subtract the mean from that that random variable, and you have to divide it by a standard deviation. When you do this, it will convert into what? Normal. Okay, or maybe I can say set to come, right? This is what standardization is. Okay, so when your x is already normally distributed, so in the given question we have x is normally distributed. So what does this mean? X is normally distributed with some mean, and so I can say that x is normal with mean mu and sigma, standard deviation sigma. So if I wanted to convert this into standard normal, so standard normal, I can say, how can I convert this into standard normal? I just have to subtract its mean and divided by standard deviation, then it will be converted into standard normal with mean 0, and so it will become a symmetric actually, right? So for example, let's say how my normal distribution will look like. It will be, suppose it is like this, right? Okay, so it is having some mu here, mean here mu x, and it is having some standard deviation sigma. So when I subtract mu, what will happen here? So when I subtract mu, then it will shift, right? So the mean will shift to x equals to 0, right?
Yes, sir. Yes, sir.
Okay, x equals to 0, and when I divide it by sigma, then the standard deviation will also it will go to what? 1.
1 by sigma it becomes 1.
1, right? So yes, this will somewhat look like this. So it will what operations we have done here is, so sigma will become equals to 1. So what operations? So we have translated x, right? And then we have divided by sigma.
Sir, how did sigma become 1, sir?
So okay. So when I divided by sigma, how I will value is, okay, so when x is normal with mu and sigma is there, right? So what will be the variance of x?
Multiplied by that constant. So we multiplied with 1 by sigma. So standard deviation was sigma. When it is multiplied by 1 by sigma, it becomes 1.
Oh, sorry, can you repeat it, please?
Anytime, like we have properties of variables. Now, if you add something to every value, then mean same number is added to mean, right? So in the same way, when you number is multiplied by some constant, then standard deviation is also multiplied by that constant. So here we have.
So it is from statistics 1, right?
Yes, sir. Yes, sir.
Yes,
yes, sir.
So we have studied in statistics 1. There are certain properties, right?
Yes, sir.
So when I multiplied with the constant, what will happen to the new constant, right?
Yes, sir.
And what so when x is normally distributed means what? There are a lot of values taken by x, right? Or
Yes,
the range
sir.
of it.
Yes, sir.
And when I am saying that I'm just wanted to subtract the mean from each of the value, what will happen to the new mean?
Sir, it will shifted.
It will shifted by something,
By
right?
something,
And when I multiply with some constant to every value of the random variable, what will happen?
Sir, the mean will also
same will be multiplied with standard deviation.
Standard deviation. Yeah.
So new standard deviation will become what?
1 by sigma of
into,
old standard deviation.
So constant into old standard deviation, right? So
Yes,
the
sir.
constant is what here? So if I'm multiplying with 1 by sigma, so the constant is 1 by sigma. Into old standard deviation is what? Sigma. Sigma get cancelled. So the new standard deviation will become 1, right? Same property if I apply with mean. So new mean will become, new mean is equals to what? So here what I'm doing, I'm just subtracting. So old mean minus
new mean.
Constant. So new mean becomes old mean minus the constant, right? So old mean is what? Mu. And which constant I have subtracted with? So new mean becomes
0.
That is what, right? So new mean becomes 0, and the new standard deviation becomes 1.
1.
Okay, and that is called as a standard normal, which is Z01. And then we are going to find the values from this FZ values, right? So FZ of -2, FZ of -1.5, FZ of -1, like this. Understand? Everyone understand this one?
Yes, sir.
We got new.
It's a new random variable. X minus mu upon sigma, it's a new random variable.
Yeah, and for that we have the PDF from
CDF values. PDF it will be 1 upon √2. Now sigma is 1, so 1 upon √2 pi, and e to the power minus, if it is a e to the power minus x upon 2 square, right? Okay, this is correct.
Sir, when we standardize a random variable, what is the impact on the PDF basically?
So
Means
impact on
what
PDF
is the
means what you
relationship
wanted to
between the
say.
PDF standardized random variable and the random variable from which has been standardized?
Okay, so can you tell me before? So take an example and tell me what is the PDF before. So for example, for a normal distribution, what is the PDF with mean mu and sigma, standard deviation sigma?
It is 1 by sigma into root 2 pi
e to the power minus x minus mu to the whole square by 2 sigma square, right? That is a PDF.
Yeah.
So when I say sigma equals to 1 and mu equals to 0, what will happen?
Then I just have to substitute those values in the old PDF, no sir. But I'm asking that PDF is of old variable, right? But now I have a standardized new variable.
So okay, what
why
is
I'm
this?
substituting its values in old PDF? I'm not getting
Okay. Can you tell me what is this? This normal mu sigma, right? And this is the new variable with normal 0, 1. What happened? The it is shifted as well as the shape of the PDF will change, right?
Yes.
Shape of it changes, right? Because previously the standard deviation of sigma, right, some value, and now the standard deviation is 1. What happened? It shrinks, right? If my sigma is greater than 1, then if I standardize it, what happens? The standard so that it shrinks, right? The shape changes. First of all, the PDF shape of the PDF changes, correct?
Yes.
And what happens again with mu? If you change the mean, it doesn't matter hardly, right? So because it is just get shifted. But when you change sigma, what happens is either the PDF will get shrink or it will get flatter, right? So like this, it just have the impact of on the shape of the distribution.
Yes, sir. But the nature of distribution will remain same, sir.
Nature will be same, right? Nature will be same. We don't want to change the nature, right? If I wanted to change the nature, then that doesn't help me, right? Because why we are actually shifting it to standard normal is because all the values are available for us, right? The probability values are available for us for the standard normal distribution.
Yes.
Otherwise, because if it is not, then we have to find it like it is a rigorous process, right? Again to find, and we don't know the CDF for the standard normal, right? No, not standard normal. Any normal distribution, we don't know PDF. And if you have different values
standard
for
normal,
mu,
we know, so we can use
yeah,
that.
and if you have the different mu and sigma values for any normal distribution, it will be very hectic for us to find every time the values of
So suppose now, like we are talking about normal distribution. Suppose I have a exponentially distributed continuous
Hmm.
and I standardize that. So this new variable that I have found, this standardized variable, what is the relationship between its PDF and the old PDF?
Okay, so for that, I think you have to see what central limit theorem, right?
Central limit theorem.
So okay, so central limit theorem. If you okay, what is the central limit theorem is? Oh, okay, forget about it. Anyway, it will come into week 6. So if you standardize exponential distribution, you're saying, right? So how will you standardize exponential distribution? Suppose x is exponential. What value you want to take here?
Take simple one, sir.
Lambda equal to 1. So how this shape will look like?
Okay, so it will start at 1 and go down. PDF.
Yeah, it's PDF now, so it will start from x equal to 1. Then,
it will be like this, right?
Yeah, x equal to 0 will be its f. Y equal to 0 will be its s.
Okay. So when I standardize it means what I'm going to do? I'm just okay. And what is the lambda here?
Lambda is 1.
Lambda is 1. What is the standard deviation here? 1 upon lambda, right? So 1 upon 1. So
mean is also 1, and
variance is 1 by lambda.
Standard deviation is also 1.
Yes.
Okay, so then this will become x minus 1 upon 1.
Yes.
So what will happen in this case? What is the distribution of this variable?
So it should also
it will
be
start from
exponentially
minus 1.
distributed.
It will start from minus 1.
Yes. Yes.
Okay.
It should also be exponentially distributed, which is just.
Okay, but it is just shifted to minus 1, right?
Yes, sir.
And what other effect you will feel again? So when x equals to minus 1, in that case it will, okay, what will be the shape of it? So okay, in this case, what is the standard deviation? How can I show the standard deviation here?
It hasn't changed, but standard deviation is like variance in the values that it takes, right?
But okay, in this case, it is not changed, right? So let's say in this case, let's say it was 2. Then in that case, mu is equals to what?
Mu is 2. Mu is 1 by 2.
1 by 2.
1 by 2, right?
1 by 2. Yeah.
Okay, and because 1 upon lambda, right? And what is the variance?
1 by 4.
Variance is 1 by 4.
And
1 by 2. Sigma becomes 1 by 2.
1 by
1 by 2.
Sigma becomes 1 by 2. Yes.
1 upon lambda square, right? That variance.
1 by lambda square is variance. Yeah, yes.
So standard deviation will be 1 upon lambda only, right? So 1 by 2 divided by 1 by 2. Okay, what will happen now? This will change. This will shifted to minus 1 by 2, right?
Yes.
Okay. So same thing. It will shifted to minus 1 by 2. Okay. Now what will happen to the standard deviation? It is also what? So it is become half. So what will happen to the shape of the distribution?
1 by 2, right?
So what here it was a shape, right? Because if I'm saying it is mean, so it will be sigma equals to 1, right? Or maybe in this case it was 1 by
2.
1 by 2 previously. Now with this random variable, suppose y is equals to x minus half divided by 1 by 2. In this case, what will be the sigma? What will be sigma? New sigma.
Now, so sigma
or shape will change or not?
So sigma will become like 1, right?
Sigma will become
Sigma will become 1.
Sigma will become
1.
So so any changes in the shape?
So obviously, left side it is shifting, but apart
left
from
side
that, I'm not
50.
able to.
Okay, so okay, this will become like this, right? 2 times x minus 1 by 2, right?
Yes.
Correct. So this will become what? 2x minus 1. Okay. So how will you find the distribution for this kind of variables? You have studied functions of random variable, right? Okay, so you can do one thing, just find is it functions of random variable you have studied for continuous distribution?
Yes,
right?
we have studied, sir.
In this week or maybe in the next week it is there. I'm not sure.
In this week, sir, it is there.
No, in week 5 only continuous function.
Week 5. Okay, week 5 it is there, right? So I'm not sure. Okay, how many of you have studied this? Okay, so without understanding.
In stat 1 we have seen, sir.
But that is for discrete, I think. I'm not sure. Like you have studied for continuous.
For continuous in week 5 it is there, sir.
Yeah, I know. So okay, just go through this. Okay, then we'll discuss this one. See, if you are able to find the distribution of y, then you are definitely able to find mu and sigma, right? For that y, correct?
So for y, mu and sigma is 1, sir. Sorry, sigma is 1, sir. Right.
So you check. I'm telling it to you. Okay, this is fine. Okay, this we'll discuss it then. Okay. So one thing is clear that that is visibly clear that it is shifted to 1 by 2. That is correct. Now the shape will decide by what factor actually? Shape is decided by sigma, right? Shape of any distribution, it will not any, but yeah. So most of the distribution is decided by standard deviation, correct? Mostly. Mean value doesn't. So it depends on the sigma value how this will look like. Okay, so you'll just find out first of all, study that week 5 functions of a continuous random variable. Then you find the value for this, the standardized, because standardized normal variable is a new variable, right? It is a function of a old random variable. Okay, so yeah, so you have to find the distribution for a new random variable, and if you are able to find the distribution of new random variable, you are easily able to compare the distributions between the previous one and the new one, right? So you yourself are able to understand what changes happen to a random variable. Okay.
But for this week we have to only focus on standardizing normal variables.
Yeah, standard normal variable. Don't worry about this now. But again, see, this is again it will come in the this when you study central limit theorem and everything. Again, all these concepts will come there. So anyway, it is needed there also. It's fine. Okay. Okay. For now, okay. Okay. For now, focus on the what? This one, normal distribution. Only normal distribution and how to standardize it. So shall we see the solution now?
Yes, sir.
Okay. So here mu is 46 and sigma is equals to 15 given. We need to find probability that x is lying between 16 and 61, right? So we'll just standardize x. So whatever operations we are going to do on x, we have to do it on
these values also.
These two values also, right? Left hand side and right hand side. So to standardize a random normal distribution, so normal distributed random variable, what we have to do is we have to subtract mean and you have to divide it by a standard deviation. So here mean is 46 and standard deviation is 15. So same operations I have done on both the sides. So it is 16 minus 46 by 15 and 61 minus 46 by 15. So it will, this value become -2 and this value becomes 1. So I know that, and what is z now? It's a continuous random variable with, it is, right? So it is a continuous standard normal with mean mean equals to 0 and standard deviation equals to 1. So you know that how to find the probabilities between a and b if a continuous random variable is there. So it is just like that, right? So it is f of b minus f of a, right? So b here is 1 and a here is -2. So it is fz of 1 minus fz of -2, right? So fz of 1 we can find it from here. So it is 0.84134 and fz of -2 is what? -2 is given. Okay, it is given. So 0.02275. If I plug in the value, it will be 0.81859. So, and I think we have asked for the percentage, like how many percent of the scores are between this. So to find the percentage, what you have to do? You have to multiply it with the
100.
So the correct answer should be 81.85 or 81.8%. Okay. Okay, I think. Okay, so that's it.
Sir, actually, in the assignment, sir, one of the questions was given like with the percentage, like the range was given here as 16 to 61. But in the question of the assignment, it was given like it is not more than 15.8%. So should it be like x less than 15.8?
Okay, I need to check. Okay, maybe it is a graded assignment question. Huh?
It's a graded assignment question, so that's why I'm just asking you a clue about it.
No, 1 minute. I'll just wait. I'm going to open this.
Graded assignment 4.
Wait, give me time to.
Yes, sir. Yes.
Week 4 we assignment, right? Question number, which question is this?
7.
A firm produces machine with lifespan which is the mean of this and standard on this. The firm is to introduce
So, have we solved all the questions for cleared today?
Yes, it's completed. Those who want to leave this, you can leave. So the YouTube link will be updated by tomorrow. So not today, tomorrow. Okay, so 15.8%, right? So hint is also given there. Probability of Z is less than -1 is 0.158. So here, x is a random variable, right? And it has given mu as 150 months and standard deviation is 40. Here,
that is, you have to find out the
probability that x should be
less than 15.8.
No. It's a probability, right?
Yeah.
Okay, so it should be like this, right? So it should be like this. Probability that x should be I need to find the value of x actually, right? So I have given the probability value. It's 15.8% means the probability, right? It's 0.158. The probability that x should be less than or equal to x, it should be equal to what? 0.158, right? Because I don't need the probability should be going over 15.8%, right? So if I now you can do the standardization on this.
Okay, sir. Okay.
Now I think you understand what I'm trying to say,
Yes,
right?
sir. Yes, sir. I'll try it, sir. I'll try it.
Okay. So I think that's it today. Yeah.
So
So
the previous question, the question number 6.
oh, okay. Sorry. I forgot. So that is a discrete random variable, right?
Right. The CDF was given with some ranges, and we need to find the probability
Find
of
the probability that
x
x
equal
equals to 0. So this is okay. How
0. For x equal to 2, I'm a bit confused.
Okay, fine. So just we'll try to draw this figure. So can you tell me?
Yeah.
Do you have this question with you?
Yeah, I have it.
Okay, can you tell me the CDF?
Yeah, for 0, for x less than 0, it's 0. For 0 less than or equal to x less than 2, it's 1/4. For 2 less than equal to x less than 4, it's 1/2. And for x greater than or equal to 4, it's 1.
Okay. So if I wanted to draw this, okay, or else we can find a PDF from CDF, and then we can find the answers also. So okay, which way is better? Then do you know how to find the PDF from CDF? We'll do that.
Okay.
Okay. So how to find the CDF from PDF? Sorry, PDF from CDF. Huh? Okay, fine. Okay, we'll draw the graph. It's fine. Let's say fx of x is there and x is here. So when x is less than 0, it's 0, right? Okay.
Yeah.
Between 0 to 2, it should be 1/4. So, and it is a constant. So it should be, so let's say 0 to 2. This will look like this, right?
Yeah.
This is 1/4. This value is 1/4. Okay. Between 2 to 4, it is what?
1/2.
1/2. So let's say it is here and it is like this. Okay. And between and greater than 4, it should be 1, right? So this will look like this, right? The step function. It's correct?
Yeah.
Okay. Now I wanted to find out probability that x equals to 0. So to find probability that x equals to 0, okay, at x equals to 0, how to find the probability here? Okay, it should be
So
1/4.
1/4. Yeah, from the question it's clear.
Okay. 1/4. what is the so this is 1 by 2 and this is 1 by 2. Is it 1? What is this height? What is this jump? It's 1 by 4.
1 by 4. Yeah.
Here
1 by 2 plus 1 by 4.
1 by 2 plus or
It's
1 by 2
4. 1
minus?
by 2 minus 1 by 4.
So this should be 1 by 4. Okay. And what about this? It is 1 by
half.
2. So at if I wanted to find the probability at some point, so this point, what will be the probability? This
1
one
by 4.
is right.
Oh, okay.
Correct?
Yeah, yeah.
And if I wanted to find probability that x equals to 4, it
1
should
by
be
2.
This is right. Okay.
Right. Okay.
Or you can actually convert this CDF into PDF, and so once you so not PDF, it will be PMF. So if you convert into the PMF, how to convert, you know, right? So you just have to subtract the values, right?
Right.
So if you do this, then you will also get the values at every point. So now can you tell me what the PMF will look like? So it will take values as 0, 2, 4, right? And the probabilities will be 1 by 4, 1 by 4, and
1 by 4, 1 by 2.
So this is the PMF.
Okay. Okay, sir. Got it. Yeah.
So that is what. Okay. So okay, so we'll wind up today. So thank you for joining.
Thank you, sir.
Yeah. Thanks, guys.
Thank you, sir.
Thank you, sir.
Yeah, thank you, guys. I'm stopping the recording.